Wow. What a way to start off our talk, Paul. It was almost straight out of a movie, wasn't it?
That's right.
I hear you mentioned the CEO wanted more music, more dramatic in that video, but it's a perfect way to set up our last session here. I want to thank everybody at Rise, as well as all of you for staying around for this last session here before we wrap up the whole conference. And I'm very pleased to have Paul Eremenko to be here in Hong Kong to tell a little bit about what's going on at Airbus right now. Obviously, he's one of the key figures trying to innovate the industry and really shake up aviation, and it certainly is a very exciting time for you, Paul, and I want to thank you. Let's talk about just for your background first. You were born in Ukraine, you're a Silicon Valley guy, and then now you end up in a European institution. Tell us how you even got here in the first place and why Airbus.
Sure, absolutely. Well, first of all, thank you, Vahana, and thank you to all of you for sticking with us through the last session. It's been quite a wild ride, I have to say. I've always been a lifelong aviation buff. I got my pilot's license before I got my driver's license, and I took a few detours in that trajectory. One of the absolutely fascinating things that I saw happening in kind of the mid-2000s was the fact that that the real innovation in aerospace wasn't really coming from aerospace anymore.
Right.
And we saw things, great innovations that were originally aerospace innovations, things like gyros, accelerometers, GPS receivers, a variety of different sensors that were created over decades in the aerospace industrial complex. And we saw all of those things coming back into the aerospace industry to disrupt the industry, but from non-aerospace players. And so this was the rise of companies like DJI, right, which leveraged the mobile hardware ecosystem and took these fairly expensive aerospace components and leveraged the fact that they have been commoditized in volumes of billions, driving their costs to nearly zero to create new things and experiment with flying vehicles. And so you saw a lot of innovation coming from outside of the traditional players, which there's just a handful, right, that you could list on one hand. And so that's not the world that we have today, of course. And I really saw that kind of the beginnings of that in the mid-2000s, which is what caused me to leave DARPA. I was in the Pentagon, the Pentagon's Advanced Research Projects Agency.
You mentioned you were an aviation buff for most of your life,
yep.
But in terms of your career, I mean, aviation, commercial jets, it's still a bit new to you. Do you think that was actually a handicap, or was it more of an asset for you in playing this role now?
Well, so I think what you're referring to is the fact that large commercial aircraft are new to me. Yes, that's right. So I come from a world of drones, rotorcraft, launch vehicles, satellites, have worked on all of those things. So coming to Airbus, it is true. I've never worked on a large commercial aircraft before, so it's been a steep learning curve for me in the last couple of years. I think it's both an asset and a liability, of course. So on the one hand, I have to, of course, draw on the expertise of the gray beards around me. And there are many of them at Airbus that really know the airplane down to the nuts and bolts, and they've been tremendously supportive. On the other hand, it is a fresh perspective, and a lot of the innovation that's coming into the aerospace industry now comes from outside, and that wasn't the case 10, 20, 30 years ago when we started out in this industry. So today you see electrical technologies, for instance, which are principally driven by investment in the automotive world. You see digital and electronics technology that I mentioned coming to aerospace. And so it's a tremendously exciting time. It's also a tremendously challenging time for industry incumbents like Airbus.
You mentioned about DARPA. You were also at Google before you joined Airbus as well. What experiences do you get from those, your past jobs and positions, and how can you apply that to Airbus now?
Yeah, so DARPA is a pretty unique place in the U.S. government bureaucracy. For those of you who aren't familiar with it, some of the stuff that's come out of DARPA over the years, I guess in the very early days of the agency, was the Saturn V rocket motor that was developed by DARPA, and then over the course of many decades, ARPANET, the predecessor to the internet, of course, GPS, original UAVs, the Amber UAV, in the 80s, came out of DARPA. So just a whole host of iconic innovations. And it's a pretty small agency and has a radically different business model than the rest of the Pentagon sort of innovation machine. And probably the biggest takeaway from my DARPA experience is the importance of speed as a mechanism not just to be first and to get somewhere first, to market or to the battlefield, but speed as a way of incentivizing risk tolerance among engineering teams. That engineers, I think, are, and all of you probably recognize this maybe in yourselves, right? We're weird creatures. We're not necessarily like coin operated, right? So just dangling a financial incentive isn't necessarily going to make somebody do something or do it better or do it faster. But if you ask a team, how long is it going to take you to build this? And they say, okay, it's going to take me 18 months. And then you say, okay, do it in 12. They go back and they think about, well, how are we going to do this? And they'll probably have to take a few moonshots in the course of trying to compress the schedule. And once in a while, they land the moonshot. And so I found that speed, and I think this is the recipe to a lot of what DARPA has done over the years, is that speed is one of the keys to unlocking that acceptance of risk. Turning to Google, as I mentioned, I think one of the things that enticed me to go to Motorola when it was first acquired by Google, and then into Google when Motorola was sold off, was looking at this consumer electronics world, the consumer hardware world. So I was one of the few people at Google working on hardware, a modular smartphone platform called Project Aura. And really getting to know this ecosystem, which incidentally moves at lightning speed compared to aerospace, and is increasingly important for aerospace. So I think those are probably my two most important takeaways.
What do you think is the most challenging thing in this transition for you? I'm sure there's a lot of traditional engineers out there that might say your ideas are crazy, and there might be some teething issues in trying to bring that kind of technological innovation to a traditional company like Airbus. What do you think has been the biggest challenge?
I think the biggest challenge is the fact that, I mean, Airbus is a great company that built some unbelievable products that you all saw, right? Some of the greatest, I would say, accomplishments of humankind in terms of building really complex cyber-physical systems at tremendous scale, at enormous scale. I walk into an A380 final assembly line and I still get goosebumps every time. And so it's a company that does that, and it does it very well. And these products are extraordinarily reliable. They're extraordinarily safe. But the world around us is changing, and so I come into this company with a very strong mandate to get the company to change to accommodate the external technological context, which moves much faster. And so a lot of the challenge is around how do you adapt the organization without breaking it? Because it really, it's a great organization that builds fantastic products. Creative destruction is kind of what your CEO described for what you're going to be doing now. Yeah, and I think it's less about destruction, because you don't want to destroy what's there, because what's there is amazing. Yeah. So you want to mold it and make it move much faster and be much more open to the outside world without compromising sort of our ability to build these great products that are extraordinarily reliable. So how do you take risk, first of all, accept failure and move really fast in the upfront development process, but then still build these amazing products? Yeah, you mentioned about speed. How far do you think Airbus still needs to go in terms of bringing technology and innovation up to speed right now? Is it just the beginning for you guys? Absolutely, and we've done a lot over the last year or two. Both at the very core of the business, how we approach the development and the maturation of technologies for our future generation products. So we've pivoted rather sharply from just a portfolio of projects that you march down what's called the technology readiness, the TRL scale, which is a thing that NASA developed back in the 60s and 70s. And we've moved rather sharply towards using flight demonstrators, very rapid sequential flight demonstrators, in order to demonstrate whole bundles of integrated technologies as a way of both providing that maturation pull and also sort of definitively measuring, right? There's nothing quite like a flight test to establish whether a technology works and is mature enough. Perfect segue to Katana talk about what you're currently working on. Of course, everyone
everyone wants to hear about Airbus's moves in flying cars, but there's just so much going on right now. When you take a look at kind of large commercial aircraft, you take a look at innovation, you take a look at urban mobility. What are you currently working on right now, and what excites you the most, Paul?
Well, first of all, I think it's important to maybe briefly describe the landscape in the company, right? You saw many of the product examples, but about 2/3 of our business in Airbus is large commercial aircraft. So that's really the bulk, the core, the flesh and blood of the company. We are also the largest provider, the largest seller by market share of civil helicopters in the world. We are in the commercial satellite business, and we are, of course, also in the defense business. So I guess first maybe I tackle large commercial aircraft because that's the bulk of it. And here my job is to prepare the future, right? So you all know the existing iconic product portfolio, the 320, the A330, of course the A380, and the newest, which is the A350. And so we are thinking what's next, in essence. And we're looking at technologies like electrification, like connectivity, like digital design and manufacturing for how we build the next generation and the generation after next product. And probably on that one of the more exciting developments that's coming, and it also ties into a bit into the helicopter business and urban air mobility, is the power of electricity as a way of delivering propulsive energy.
Could that become reality soon?
Well, in terms of pure electric propulsion, with the existing landscape or even the projected landscape of battery technology, pure electric is not in the cards by a couple orders of magnitude. However, you can do a pure electric vehicle at the 1 to 4 person, 1 to 4 passenger scale, and get cross-city range. Right, so something under 100 kilometers kind of range, and be able to take off and land vertically. And so from that perspective, that's probably the most near-term application of electric flight, is to what we call urban air mobility, which for us is one of the possible futures of the helicopter business. And we can come back to that because I think it's an important one. But then just to come back to commercial aircraft, here electrification is also incredibly important, but it will probably take the form of hybrid electric propulsion. So you would still have a turbine that would drive a generator, but then you would distribute the electrical power to a variety of motors around the aircraft. And you might ask, why would you ever do this, right? Because the end-to-end efficiency is a bit lower because you have an extra conversion step in the end. But what it does is it opens up the opportunity from an overall aircraft design and configuration perspective. So it lets you do things like optimize for cruise and then have a battery for takeoff, for instance. It lets you do things like shrink the wing because you can now have distributed propulsion that blows over the wing. You can get rid of the vertical tail surface because electric motors have really good response characteristics, so you can yaw the airplane instead of with a rudder through differential thrust. So it opens up the design space, and I think for the first time, we might actually see, for the first time really since the jet age, since the 1950s, we might see a significant change from the traditional tube and wings configuration that we're used to today in large commercial aircraft.
To build a passenger jet right now, it takes about 7 years or so from the drawing board to the runway. What are you doing to actually speed up that process right now? And are you tapping into different industries to try to do so and actually quicken the pace a bit?
Yep. It's an incredibly important question because I think the first one to crack this nut in any sort of heavy industrial application is going to have a tremendous competitive advantage. So it's an area that we focus on quite a bit, which I term digital design and manufacturing, end-to-end digital continuity in the design and manufacturing process. And I think, for me, the real model is what happened with electronic design automation and foundry-style manufacturing of semiconductors in the 80s, right? So this is Conway and Mead that came to the realization that by automating the design process and by imposing a set of design rules, you may produce something that's a little bit less optimal, but you can do the design much faster and improve the productivity of designers, and you can virtualize much of the verification and test through simulation. So that then the first product that you build is usually correct by construction. Okay, in chips usually you build 2. but all right. And then you can separate design from the foundry style kind of reconfigurable multi-purpose factory.
Okay.
And I think that a similar thing, I mean, a similar sort of by analogy, not literally identical, could apply to aerospace. I think automotive has made some inroads in this area, but they have a very different problem than we do. They manufacture in very different volumes with relatively low variability. We manufacture in low volume, but very high level of variability from product to product.
Do you have a target, or in 10 years, what do you want that rate to be? Cut from 7 years to what?
Yeah, well, it's a difficult question, just because frequently what we build are derivative variants of specific products. But I think it's not inconceivable that you could get 3 to 5x compression, roughly speaking, of the end-to-end development and production ramp-up of a complex system like an aircraft through digitization.
Great. And talking about, moving on to helicopters, we can talk a little bit about, this Racer, which is the rapid and cost-effective rotorcraft. You debuted this during the Paris Air Show not too long ago. Cruises at more than 250 miles per hour, which I thought was incredible. It's said to be one of the fastest helicopters out there in the skies. Got wings, propellers, main rotors. I mean, is it a plane? Is it a chopper?
Yeah.
Tell us a bit more about this technology. And
sure.
Who would actually use this type of a chopper?
Yeah, so Racer is one of our sort of X-planes, if you will, one of our prototype aircraft. It's actually the second iteration on the same type of technology, bringing it a bit closer to potential product application. And it's what's called a compound helicopter, which means that it has a main rotor, but it also has a forward propulsor and some lifting area as well, which allows it to fly much, much faster than a conventional helicopter, which just uses the tilt of the main rotor disc for forward propulsion. So it has one of the main issues with that helicopters have is speed, is the fact that they're speed limited. And so this is our attempt to expand on that axis.
Wow. I think current top speed is like 160 miles per hour, right? And this is going to bring it to a whole new level. Yeah. How far is it from being available?
Well, it is still a flight demonstrator,
yeah.
right? So there is not a specific product that we are targeting for it, but it should fly in the next few years.
Okay, we got to talk about Vahana, which is of course the flying car project that you're working on. I mean, there's dozens of companies out there, Paul, that are pursuing something very similar, right? Vertical takeoff and landing vehicles. What sets Vahana apart from everything else right now?
Yeah, well, first of all, this is the incredibly exciting thing about being in aerospace today, is the fact that you actually do have something like 20 startups building vertical takeoff electric vehicles. Like, that's amazing. If you had told me that when I was in college, I would have been like, wow. So we have actually two vehicles in this space, in the electric VTOL space. We have Vahana, which is a single-seater, which almost by definition means that if you want to have any sizable market, it has to be autonomous. You can't just limit it to pilots. And then we have a second vehicle called City Airbus, which is a little bit bigger. It's a four-seater vehicle. And the Vahana is a tilt wing configuration, whereas City Airbus is just a pure quadrotor, a pure lifting quadrotor. And both of these are aimed at this market of urban commuters, of urban air taxi or urban commuters. So the ability to move around cities, basically open the third dimension. The promise that helicopters never quite fulfilled because of noise, fundamentally. Noise and perception of safety. So you see helicopters doing a pipeline inspection or going to oil rigs and shipping equipment and some transport in some cities, but by and large they never really opened up the third dimension in the way that the Jetsons or that you might have seen you see in sci-fi film.
Well, what's the aim? What's the aim for it though? Is it more of a democratizing flight and transport, or is it more about the technological challenge?
Well, I think you have to have both. You have to sort of conquer both, right? To conquer the latter to get the former. So, our goal really is to open up the third dimension in cities, and we believe that the time is ripe. That there is a certain convergence of social pressure, of sort of demographics and the growth and rise of megacities, and increasingly the pain of congestion. And simultaneously a technological convergence between a few different technologies that seem to reach a point which really makes the flying car, which people have talked about for decades, right? But really seems to make it a reality. And so this is electrical technology, electrification, power density of batteries, power density of motors, autonomy, lightweight, mass-manufactured composites, which actually also came to us from automotive, from things like the BMW I-Series type manufacturing processes. And so at the convergence of all of these, we suddenly see the possibility to create that these vehicles might actually be viable. Now, coming back to the competitive landscape, you are fully right. Many people pursuing this. I think that today we are the only players in this space who actually know how to build and certify a manned vehicle. A human-occupied vehicle. So for us, it's not just a very large drone, nor is it a helicopter, right? It's really something different. It's something completely different.
It's quite remarkable. I watched the video and I just thought it was like modern-day Jetsons almost.
That's right. That's right. And so I think that our sort of unique differentiator in this space is that we know how to work with regulators. We know about air traffic management, and we have the kind of skill set to build these things such that they have the kind of reliability that you would expect of flying vehicles in an urban environment around people.
How big of a hindrance is the regulations around this kind of innovation?
Well, the regulations don't exist for these kinds of vehicles, both because they're electric distributed VTOL, right? So that's a new thing from an airworthiness certification perspective, and also from autonomy operating in controlled airspace, right? So an autonomous vehicle obviously can't talk to air traffic control. So there has to be some other way of making sure that these are deconflicted, that collision avoidance is taken care of, and that they're safe also vis-a-vis other kinds of traffic, right? So legacy traffic, helicopters, general aviation aircraft.
I want to really put some time before the last couple minutes left, Paul, to really talk about why you're here in this part of the world in China. You just set up your innovation center in Shenzhen. What do you think is Airbus's current interest in China right now? What do you see?
Well, we're not new.
Yes, obviously.
So I think we sold our first aircraft to China a little over 30 years ago. We've had a permanent presence in China 20 years now, and that includes today an A320 final assembly line in Tianjin. It includes an A330 cabin completion and delivery center. It includes a helicopter design office, a big engineering center in Beijing. So we have quite a sizable footprint, and of course we recognize China as a real growth market. The Chinese demand for air travel will grow much faster than even global demand for air travel, which is projected to be quite healthy and has been quite healthy. What's new now, I think, is that China is arriving on the innovation arena. And so we are opening this innovation center. We just recruited the CEO. He's an executive from Didi Kuaidi that we were able to poach. And I think that if you look at the Shenzhen ecosystem, there is really nothing quite like it anywhere in the world. And I say this coming from Silicon Valley, which I think is also unique in its own ways. But from a speed and fearlessness of innovation and hardware, I think Shenzhen is unrivaled worldwide. And so we feel like we have to be there to capture the talent pool and to basically leverage the network effect of the supply base
And to be the next Silicon Valley in this part of the world, you think, Shenzhen, or?
Well, I think the question is, do you need to be the next Silicon Valley, or can you be the next Shenzhen, in the sense that it's something different, right? I think it has a different recipe for its success. I think it has different domains that it's successful in.
Yeah.
So rather than trying to be Silicon Valley, embrace that, right?
Final question from me, and then we'll throw it to the crowd, of course. Of course, it's going to be China's aircraft builder, Commack, making a lot of headlines these days with their C919. How does Airbus see it? Do you see this as a threat?
Yeah, well, I was watching the live stream of the first flight of the C919. I don't know if any of you did that as well. And I have to say, it's whenever there is a first flight, it's riveting and it's exciting, and it almost kind of brings you to tears. And they're good tears, right? They're tears of excitement. So we congratulate Commack on the tremendous accomplishment. I think it's great. And frankly, we welcome the competition. I think in the long term, it makes us all better. So as long as we're on a level playing field, we are happy for more participants in the space. It'll cause us to move faster and do more exciting things.
Bring it on. All right.
That's right.
We're going to leave it there, but I want to throw some questions. Anyone has any questions in the crowd, and we'll just raise your hand. I think the gentleman over there is the first hand that I see, and then we'll just wait until we bring the mic over to you. Yes.
Hi, do you have any plan for hypersonic commercial planes anytime soon?
Hypersonic commercial planes, yeah. So first of all, I would love nothing more personally than to make something like that happen. Actually, my graduate thesis was on experimental hypersonics. I think that from just pure physics and economics perspective, at least supersonic flight doesn't seem to close, right? And again, I'm as big a buff of the Concorde as anybody. I think it's one of the coolest airplanes ever. But if you look at the physics, right, to go faster, the energy required goes like the square of velocity, and the time saved goes linearly with velocity. So typically the curves don't really converge at a price point that makes sense for people. Now, it is possible that if you get into the realm of sort of very high Mach numbers, that it kind of change, where you may even go exoatmospheric for transport purposes. It changes that equation altogether. I think that technology is pretty far away. But in terms of supersonic technology, we just don't see the economics as closing as much as I would love to, just from a pure tech perspective.
I think we got a gentleman over here. You're next. I got you.
What is Airbus' plan in reducing the environmental footprint of air traveling?
It's a very good question, and you know, as a European, as a global company with European roots, as we call ourselves, it's particularly near and dear to our heart. And you know, Europe has some very aggressive initiatives on this front. Clean Sky, a series of Clean Sky initiatives that we are one of the primary participants in. I think so. We are committed, of course, to meeting the emissions targets that are set forward by the regulators and by the EU. And I think there's a variety of places where you get those emissions improvements. Probably the biggest step change that's going to happen in emissions will be, if it comes to pass, electric flight, hybrid electric flight, of course.
The gentleman over there.
Thanks for this very good talk. I was just wondering, Paul, how do you make sure that it's not only you and your team doing innovation, but Airbus is a huge organization. So how do you make sure that there's a culture of innovation in this organization? Thank you.
Yeah, also a very good one. And this is an ever-present problem, I think, in large companies that try to also innovate. And we're a very large one. We're 140,000 people. So we have a few different approaches. I think there's no magic solution, but you know, so we use, for instance, the core of the engineering community rather than just in a kind of an elite innovation core. So we use the mainstream engineering centers on most of our research, technology, and innovation projects. We structure our innovation projects in a few different phases, and then as the project progresses, we bring it much closer to the core of the business. But you know, at the very root, I think engineers like to be innovative, and so you actually don't have to try so hard. You just have to give them a little bit of breathing room and unleash them. And say, hey, you know what? It's okay to go do this, and it's okay to fail. Please don't fail on the mainline product development, but it's okay to go do this on the side. And I don't think that kind of cognitive dissonance is really so difficult to grasp for most engineers.
Gentleman over there.
What's your advice for the software developers in the next 5 years?
Well. You know, insofar as software intersects with aerospace, there are probably a few areas. One of the most important and dearest to my heart, of course, is the flight controls and avionics software. And here we have been one of the pioneers in formal methods and the application of formal methods to create provably correct software. And I think this will continue to be incredibly important and expand to more than just flight controls. And especially as the cyber threat grows, I think so has to this kind of provably correct development approach. So I think that's more efficient solvers, more efficient theorem provers are very important from that perspective. I think the other area where there's a big overlap is in in-flight entertainment and the in-flight passenger experience. And I think that we will move over the next years towards an environment where you really can develop apps for the in-flight experience, right? Whether it's for the to run at the aircraft level or to run at the individual level for the individual passengers. So I would expect platforms to arise on which you can develop those kinds of apps. And then of course maybe the third area is on the consumer facing stuff, where I think there is a tremendous amount of room to innovate in the way consumers interact with the travel experience, right? So these are things like booking engines, or today one of the things that's kind of peculiar about our industry is that from a consumer perspective, the travel experience is a bit commoditized. So most consumers will just pick the lowest fare. They don't necessarily look at what airplane it is, or they don't necessarily have a way to see what is the airline, what is the airplane, what's actually my experience going to be for sometimes 15 hours. And that's not the way we approach hotels, right? So people don't just randomly book a hotel and cheapest hotel, right? They say, oh, but I care about my amenities. And so I think that there is, for instance, an opportunity to really decommoditize the interaction of the passenger with the in-flight experience.
Let's do the back real quick. Yeah, I think someone's been holding their hand for some time.
Hi. A bit of a renegade question, but has Airbus or any other company ever considered individual flying device? Like if you want to fly from within city from one area to other, is there something that stops? Are there any regulations in place? Any reason why any company or anybody cannot consider? I mean, not idealistic, like Iron Man kind of thing. You just fly around the city.
Well, I think first of all, the Vahana, which we talked about, right, is almost exactly that. It's kind of the smallest viable vehicle in which we think you can fly safely inside an urban area. And it fits in about the dimensions of two to three parking spaces. Let's put it that way, right? So it's not jetpack kind of size material, but I do think that there's definitely a pull. Not just from people like yourself, but I think from even from the broader populace for that kind of personal transportation.
Gentleman in the front.
Yeah, hi, Paul. What are your plans to have a footprint in India on the manufacturing or assembly line? Any plans?
Yeah, we actually do have a sizable footprint in India. We also have an engineering center, as we do in Beijing. We have one in Bangalore. And we've increasingly also ramped up our innovation activities there. So we have one of our startup accelerators, the Airbus BizLab. We have 3 of them, and one of them is in Bangalore. So I think particularly on the digital and software side, it's a tremendous talent pool, and we're keen to draw on it.
Okay.
How do you drive moonshot thinking in Airbus in terms of 10x thinking to disrupt air travel?
Sorry, how do we what?
How do you drive moonshot thinking or 10x thinking in terms of disrupting air travel in your company? So the plane has been the same for the last 50 years, so it's the seats have been the same. So is there something to disrupt air travel, say 10x thinking, something totally different?
Yeah, well, so I think I talked quite a bit about at the aircraft level, right, with the kinds of technologies that may change. At the cabin level, I mentioned the possibility of creating apps, kind of an app-based platform, both at the aircraft level and at the passenger level. We do also have a few things that are a bit more radical on the cabin side. We have a project called Transpose, which aims to basically create a cabin experience out of cargo modules. And so I think the first demonstration would be in a freighter aircraft, but then of course you could have a custom purpose-built aircraft for that. And the idea is that you really add a new segment to the value chain, which is module provider, cabin cabin module providers with different kinds of experiences. So you could imagine on a flight to Vegas, you might have a casino module, or maybe in a more general sense, right? You might have a sleeping module, and you go and you pay $50 an hour to have the ability to sleep in a soundproof, sort of climate-controlled area, or a restaurant. And the airline could reconfigure this in between flights. So it takes about 15 minutes to load and unload such a module. And so depending on you could even customize it to the actual demographics of the people on that flight, right? And say, okay, these people want these kinds of experiences, and so we load them on. So we are about a year into that project. We've built a full-scale terrestrial mock-up and have been doing user trials to understand what people like, what people don't like, what's the actual value to the airline of such a creation, and next up would be flight trials. So that's probably one of the more disruptive things on the cabin experience side that we have cooking.
It's almost like having like a hotel room, kind of, right? Or you're
could be. It
kind of like
on a long haul flight. Yeah.
Yeah, very cool. We'll
Absolutely.
probably have time for one more question. We'll get over there in the
Make
middle.
it a good one.
Yeah.
How far are we from getting rid of the pilots in the airplane?
That is a good one. So, of course, most of the obstacles to unpiloted flight are, I think, in the regulatory, the air traffic management, and the public acceptance domains. So the fact that you can autonomously fly, it's actually easier to fly autonomously than it is to drive autonomously, because you don't have kids and dogs and other kinds of things sort of flying off the vehicle in front of you, usually. And so the problem fundamentally is not a technical one. And we believe that that first autonomy will come in this domain of urban air mobility, where the vehicles are smaller, there are fewer occupants in the vehicles, and they will really follow in the path that's being paved by the self-driving car industry. And so that I have fairly high confidence that we will get to, in sort of single-digit years, and then we will see what is the social acceptance of these kinds of things. I think if history is anything to go by, the appetite of the public to accept will be very high, and then scale up from there.
Yeah. Show of hands. Who would want to do that? All right, we're going to leave it there. I want to thank everyone for your questions, and of course, I want to thank Paul so much for coming to Hong Kong and spending time here at Rise here today.
Thank you all.
Paul
Thank you,
Aramenko, CTO at Airbus. Thank you.